Let's run one iteration and look at the effect on the cell center values. Highlight run calculation, set the number of iterations to be 1, and say calculate. I'll say OK here. That reports the residuals, the aggregate, mass and momentum imbalances. We'll come back to that. But before that, let's take a look at what the cell center values of axial velocity look like. I'll go back to contours, double click on it, and say display. So we have run one iteration, which means that all these cell center values have been tweaked once. And you can see, for instance, this particular cell, it's gone from an axial velocity of 1 to something like 0.7. In fact, I can see where in the range is by right-clicking on the cell. So that's around 0.7. So you can see the effect of the boundary condition on that cell. You can also look at the mass imbalances. So I'll say contours of residuals, mass imbalance, and say display. So if I look at this particular cell and right click on it, the mass imbalance is about 10 to the power of -6, which means that the mass going out minus the mass coming in is of the order of 10 to the power of -6. And you can add these mass imbalances for all of them, and then the absolute value, and scale it. And because of the scaling, it says that value is 1. So you can see it's gone, because of scaling, instead of the order of 10 to the power of -6, you're getting off the order of 1. And we want to reduce that by a factor of, we want to reduce that to by 6 orders of magnitude. Similarly, for the momentum imbalances, unfortunately, you can't look at those imbalances by default over here. And so we can go ahead and do more iterations. Let's do that next.